this exciting activity. We will examine the outside of the kidney and then cut it open to identify the structures inside the kidney. In this dissecting activity, we will be using the scalpel to cut it open or a scissor. The kidney's location is against the dorsal body wall, in a retroperitoneal position, behind the parietal peritoneum. The right kidney is slightly lower than the left due to position of the liver. An adrenal gland sits the top of each kidney. And now, let's dissect the pig's kidney. As we know, the shape of this kidney is like a bean, and the kidney of a pig is the same as the kidney of a human. In cutting a kidney using a scalpel or a scissor, make sure that you only get one chance to cut it, and there's no way to redo this. And be careful to cut because it is a soft tissue.
The renal cortex is the outer layer of the kidney, responsible for filtering blood. It contains the glomerulus, where blood pressure pushes plasma into the Bowman's capsule, starting urine formation. The distal convoluted tubule regulates ion balance and pH by selectively reabsorbing or secreting ions. The renal medulla is the inner region of the kidney, organized into renal pyramids. It contains the loops of Henle, which create a concentration gradient to reabsorb water and concentrate urine. The descending limb of the loop of Henle allows water to leave the filtrate, while the ascending limb removes salts and conserves water. Also, collecting ducts run through the medulla, where they further reabsorb water under the influence of hormones like ADH.
Then, we have here the renal pelvis. It is the area at the center of the kidney and acts as a funnel for urine flowing to the ureter, the tube that connects the kidney to the bladder.
The renal vein collects the deoxygenated clean blood and returns it to the bloodstream. The kidneys remove waste products, excess fluids, and electrolytes from the blood through filtration. The renal arteries are central for delivering oxygen-rich blood to the kidneys so they can filter and remove waste, excess fluids, and electrolytes from the blood, forming urine. Each renal artery splits into segmental arteries which further divide into smaller branches called interlobar arteries.
Let's go now with the ureter. Here in pig's kidney dissection, the ureter is a crucial structure that plays a vital role in the urinary system. It's a muscular tube that connects the renal pelvis, the central cavity of the kidney, to the urinary bladder. During dissection, you'll find the ureter as a tube extending from the kidney towards the bladder. It's often located near the bladder, and if you can find the bladder, you can trace the ureter back from the kidney. The ureter is responsible for transporting urine from the kidney to the bladder for storage. This process involves smooth muscle contractions that rhythmically propel the urine downwards.
Here, we will be seeing the inside of the kidney. We will use spins to discuss the functions that they have. This outer layer of the kidney, just as darkish brown color, we refer to as being the renal cortex, identified by the yellow pin. Moving inwards, each segment that you can see inside the kidney, we refer to as being a renal pyramid, identified by red pin. Feeding in the center area, we have the renal pelvis that feeds into the ureter and transport the excretion area products out of the kidney towards the bladder. The darker red color that you can see, because its higher density of blood vessel, it is the renal medulla, identified by blue pin. Then this is the parts inside the kidney. The renal pelvis is a hollow structure that feeds into the ureter and extending from the pelvis, our collecting ducts, which go to the medulla. You can see the tubules that connects to the collecting ducts reach into the medulla, which are connected to the nephrons, and there are approximately 1 million nephrons per kidney. The function of the kidney is to remove toxins from the body and regulate water content, and there is a complex process of excretion and reabsorption steps. As the kidney function in osmoregulation, it also plays part in the blood pressure and calcium metabolism.